somebody else by raising hand. Different question. Please, Hannah.
Could you just like summarize that
So the basic idea is, so this was like my sequence of thoughts. My thought being that if I kind of tell you my sequence of thoughts and you can make sense of it, it's a lot easier for you to memorize what you should do. So when I read the problem, I go really slowly. And it says the function f is some formula. I don't read the formula. I just go, that's f. I do not read the formula. It's a waste of time. That's f. Where does f have a relative max? So I have to remember, well, f has a relative max when f changes increase to decrease. Good there? So I do a little Daniker's chart, note that's what I'm looking for. But I don't have a graph of f. I have no calculator. So I need a sign chart instead. Sign charts are substitutes for graphs. If you can do a graph on your calculator or you have a graph, don't do a sign chart. Sign chart's just like the next best thing, but graphs are always better. So I need to go figure out when f prime changes positive to negative. So how do I do that? I need to find f prime. I remember you cannot make a sign chart if f prime is not factored. So I factor f prime to here. And then I simply list the factors of f prime. And here are different values of x. And I figure out that when x has any value, it doesn't matter, 3 is going to be positive. For any value of x, 5x squared plus 1 is going to be positive. For this one, I just plug it in. If x equals 1, the result would be 0. And then I say if x is bigger than 1, positive, less than 1, negative, similar here. Multiply these 4 rows together is how you get f prime. Because f prime is really those 4 factors all multiplied. Does that make sense? Repeat for Hannah. Anyone else have a different question? Oh, please, thank you.
Well, I don't.
Thank you, Jeff. You're good. Please. Oh, very nice. All right. I still want to see the device. That's the most exciting part.
Well, yeah, I have to figure out.
But one step at a time.
Oh, yeah.
We have a different question they want to look at. Please, baby.
Just on 18, I have like a small question.
All right. Keep talking to me.
So it's the one where it's like the shadow, and I just don't understand like the ratio between a and 2 and y plus x. Y. I just don't get why that ratio works.
Gotcha. So, three more for Bailey for a really good question. You better dial back. 2 more, Bailey. Sorry, getting too out of control. So 2 more for Bailey for a really good question. Bailey, you won't be able to, in our class, go into the full why, but I'll give you as much why as I think you need to know.
Okay.
And if it's not quite enough, just tell me. But the first thing to recognize is that when you have a small right triangle that is within a larger right triangle, they are similar triangles.
Okay.
Which means the side lengths are all comparable. So this is the large side, I don't know, large side, whatever. It's this side of the large triangle. And it's 8, according to the problem. Good to there? Okay, the small triangle's here, and this side corresponds to this side. Would you agree?
Yeah.
Like if you're kind of mapping them, you say, well, this side corresponds to this side.
Yeah.
So this side is 2. Similarly, this side of the large triangle, which when I worked out the solution, I called this x, and I called this distance y.
Yeah.
So this large side is really x plus y, the whole thing. Does that make sense?
Yeah.
So what I said was, the ratio of, like 8 and 2 are compatible, they're comparable, but so are the short how do I say, this side of the small triangle as this side of the large. So you can set up a whole bunch of different ratios to state that similarity. Like you can say 8 is to 2, so as x plus y is to y.
Okay.
But you could have also said this. You could have said that side 2 on the little one and the side y on the little one compared to the side 8 on the big one and the side x plus y on the big one. Same thing. You just choose whichever one is most useful for you. I could have said this. The y on the little one is to 2 as the x plus y on the big one is to 8. That's what we mean by similar.
Okay.
Does that help?
Yeah.
And then you kind of go from there.
Yeah, that makes sense.
Question. You might have a follow-up question, please.
Can we just finish, because I got up to there and then that's.
So where I would have started the problem, of course, would be with this. Write down all the rates first. So somebody help me, I'll pay you 2 pebbles, 2 per peanut. What are the rates that are mentioned in this problem? I need you to raise your hand. Please, go, Sarah.
The shadow is lengthening at the rate of 4 9 per second.
Pause there for a second, 2 for Sarah. I need to translate that English sentence into some sort of mathematical equation. So somebody translate that English sentence into a mathematical
G
equation.
of y would be of x is equal to
Super close. dt. No big deal. dt. So Hannah looks at the picture and says, this is the shadow right here. So that length, y, is getting bigger. And what's the rate at which y grows? It's the rate that Sarah mentioned. So I write down that rate. My paper's kind of disorganized here, but somewhere I would write dr over dt is equal, not dr, sorry, dy. So dy over dt is equal to 4 over 9. That's one of the key rates. I'm boxing it not because it's an answer, but because it's a key rate to write down. Please.
Explain what dy over dt was.
No worries. So when you see D, like anytime you see stuff like this, Keely, there's a bunch of examples, that should help. 2 for Keely. You could have dr over dt. You could have dA over dt. You could have, in our case, dy over dt. They're all indicating that something is changing at some rate. This one's saying the radius changes at some rate. The area changes at some rate. The length of this thing called y changes at some rate.
And the y is the person's shadow?
The y is the shadow of the person. Because the person standing here, like kind of look at me, it helps. The light's behind me, so as the light shines, I block the light. So there's a shadow right there. And as I walk, that length changes. Is that okay? Good. So, and really the 4 over 9 tells you exactly how it changes, Keely. Because remember, dy means change in y, so it's saying the length of the shadow is going to change by 4 meters. Well, how often does the length get 4 meters longer? It takes 9 seconds. It's 4 meters per every 9 seconds. Change in the length of y divided by the change in time.
So but y could be any variable, in this case it's just y.
Yeah, the name doesn't make, it's not important. I could have called this S, T, R, Q, whatever. I just called it y. Does that help? 2 for Q. Anybody else? So we've written down those, well, we got one rate. We can't have a related rate unless there's more than one.
So it says the shadow is lengthening at the rate of 4 over 9. If it had said that the shadow was getting shorter at the rate of 4 over 9, would we make it negative 4 over 9?
Did we hear that? Like, push yourself down for 3 for that question. If the shadow is getting shorter, which would require the person to be walking the other direction, you definitely have to say that that rate is negative, that the shadow is getting shorter. It's a really good question. We still need to write down all the rates we covered. Think for help? Go.
The FTT is the way the person's walking, where the person's walking.
Very good. So x is really a length. It's the distance from the light to the person. But as the person walks, that length gets longer. And me demonstrating it seems to be the best way for me to understand it, is here's the light, the chair, and as I walk, like if I go 2 feet, and then 2 more feet, and then 2 more feet, well, I'm moving 2 feet per second. But as I move 2 feet per second, the distance is growing exactly by 2 feet every second. Does that make sense? So 2 for Ian. So the other rate is dx dt. And they don't tell us dx dt, we're supposed to find it. So I just put a little, don't know what that is, that's kind of a lame question mark, but everybody good to there? It's something I've tried to emphasize, but it doesn't always stick, so listen close. The reason you write down the rates, and pretty much the only reason, is because when you have a rate, you also have some quantity. Like this is the rate at which some amount or quantity changes. This is the rate at which some other amount or some other quantity changes. So somebody earned 2 pebbles, raise your hand and tell me, this is the rate at which what quantity changes. This is the rate at which what other quantity changes.
Red is the rate at which the length of the shadow changes, and the green is the rate at which the distance between the street post and the person changes.
Perfect. So this is the rate at which y grows. The xct is the rate at which x grows. It's perfect. 2 for Luke. Somebody answer this. Just hand, please. It says here that dy dt is 4 over 9. Just kind of explain this to me, to the class. Does that mean that this length right here is 4 over 9? So we talked about that. Brian talked about that.
Well, that's the rate, and that's the rate at which it's increasing. So it said, like y is a set length, that's the rate at which it's.
Yeah, make sure you keep those separate. 2 for Ryan. Rate is one thing, amount is something else. Rate is one thing, quantity is something. Like I say quantity and amount synonymously, I use those interchangeably, but rate is different. The reason we write down the rates is so we can identify the quantities the rates are talking about. That's the whole reason we write them down. So now I know I have 2 quantities to concern myself with. The length y and the length x. That's what I'm worried about. So when I go to the equation, part of this red, I'm looking for an equation that has an x and a y in the equation. So these equations that Bailey had me write on the board, any of those will do. They all have an x and a y. So you can choose any one of those to continue with the problem. So somebody raise your hand, turn 2 pebbles, and tell me if you want option 1, option 2, or option 3. Let's go, somebody new, listen.
Option 1.
So option 1 is a good choice. I'm actually going to steer you this way just this time. Just because if we multiply 2 pebbles and listen though, if we multiply both sides of this equation by 8, what's the new equation? Read it to me.
Sorry.
So we're going to multiply this side by 8 and this side by 8.
Okay, so that'll be 8y over 2
Let's sit down, keep going and listen.
equals x plus y.
Make sense? Perfect. 2 more for Alyssa. And then what would you suggest I do now? Somebody else, hands please. Keely.
That would be 4y.
Nice. I did that just because the algebra is so easy that it makes the calculus a lot easier. If the algebra is hard, I'm not going to do that kind of thing. So somebody have a suggestion now? Nick.
Subtract y from each side.
And what's the new equation we're going to get?
3y equals x.
This discussion is really good. 2 for Nick. Anyone have any follow-up questions? Just want me to clarify something else, like where we're headed? Want me to restate anything? Please.
So we just kind of made up our own equation for this.
You have to. Some related rate problems, they will give you an equation. But it's not uncommon to have to use similar triangles to come up with your own. Or another common one is the Pythagorean theorem on your own. Or another common one is SOHCAHTOA. Like the sine is equal to the opposite or the hypotenuse. We haven't practiced any of those, so there won't be one like that on this test. But it's going to start showing up.
Like I remember taking this in class, like where we did the radius or something. Is that like when they give you equations?
Right, so there's some related rate problems we've practiced where they said it's a sphere and the surface area of the sphere is this formula. So they helped you out with that one, and they always will. The ones to have memorized are similar triangles, Pythagorean's theorem, SOHCAHTOA, area of a circle, circumference of a circle. That's pretty much it. 2 per chelate. Anybody else here? Anything? So now when we have this, we go to the D. D says take the derivative. So we differentiate both sides in terms of T. Go out with 3. I'm supposed to be solving for, oh, that's a T, sorry, hold on. Whoa. Wrong pen. That one. Hey, look. Oh, please, come here. So, when I do a related rate problem, I always follow the acronym first. So the acronym says write down all the rates. We did that here. And we wrote down the rates so we could identify the quantities that the rates are referring to. The equation says come up with an equation involving the quantities, not the rates. So we did that here. D says take the derivative with respect to time, both sides of this equation. So I did some algebra first, but then I just followed D. Keep going.
I'm just, like, never mind.
You're okay. You always have great questions.
Okay, let me just get this one. The reason why that's not, the 2 and the 8 aren't rates and they're quantities is because they're meters.
Right, they're referencing the
Okay.
lengths themselves. So X doesn't mean, X is just a length. It's like so many meters.
Right, okay.
Y is a length. It's so many meters. It's not how, but dx dt is the rate at which X gets longer and longer.
So that's why we need to write it, is so we can change it into a, okay.
Yeah, the way related rate problems work, Trina, 2 pebbles, are you first see how the quantities are related. Okay? So we wrote down the rates just so we can figure out what quantities is this problem concerned about. We write down the quantities. We see how they are related mathematically. We then take the derivative of that equation, and it shows us how the rates are related. What it allows you to do, Karina, is you can now find one rate based on another. See, like we want to find how fast X is getting longer. This tells us X grows at a rate that is 3 times the rate of the shadow. Does that make sense to you? So that's what I write down. Shadow length is growing at 4/9. So this is growing at 12/9. Which means every time 9 seconds goes by, the distance from the light will go by 12 more meters. The shadow only goes by 4. Then they just reduce it. I got some more. Higher, please.
Going back to those 3 couple of equations, why would there be the other 2?
Alicia, sorry. It really doesn't matter which ones you use. It really doesn't matter. You do a little bit of algebraic manipulation. So algebra manipulation, and you end up with that same 3y equals x. So it doesn't matter. 2 for higher. Anybody else? Huh? Please, no.
So I understand that one, but now can we do 19?
Huh?
Because I struggle with that.
No, you're fine. It's common to struggle with the related rate. But it does seem to be the kind of problem that once you kind of do enough of them and ask enough questions, it really will click solidly. You'll be like, oh, these aren't that bad. So a good thing to do here, Chanel, is make sure as we talk about 19, that we keep referencing back to how it compares to this one. So here we go, 19. So somebody pick up 2 for Chanel for asking. Somebody pick up some pebbles. Somebody what to do. Let's go, Sarah.
So you do the R part first, and then dr over dt equals -2 since the radius is decreasing.
clarification, anything on that one? Follow-up questions? Please, Heather.
So when we're doing all these types of questions, should we always do OBDT?
For later rate nets.
Okay, when will we use DX? Is
Um,
that just for when you're finding the rate?
When you have a function that's like y equals 2x squared plus 7, because x is the input variable, you do d over dx. When it's related rate, everything in the problem is changing with respect to time. At least I've never seen another problem that didn't. Can I look up? So you take the derivative with respect to t. What you're always looking for is what's the input variable. In this case, time is the input variable. Time is the x-axis variable. Go ahead. Sorry, Luke.
So R is not, so dr means the change in the radius. It's not
Rate.
change in rate, it's just change in radius.
Rate of change of the radius. At what rate is the radius changing? The rate is always a ratio. 2 for Luke. Somebody answer this question. What's really the denominator? What are the units? Help me, Keely, help me. What's the denominator? 1 second. What's the numerator unit, Keely? If it's a rate, Luke, it's a ratio. We don't always write them as ratios, but they always are. That's why it's dr over dt.
So is the change the radius? over
Yeah,
the
it's
change
right
in
by
time?
change in time.
Okay.
Every time time changes by 1 second, radius will change by 2. That's exactly what rate means. The radius itself is different. It's whatever it is, which they tell you here, we're interested in the sphere. At the instant, the radius is 3. That's just centimeters. Totally different than the rate, totally separate. Follow-up questions? Good job.
So for this one, since they give you like the value, are you looking for the rate? Like what rate or what?
At this point in the problem, I actually don't worry about that. You just follow the acronym. Like really, if you're having trouble with related rate, always follow the acronym. 2 for Keely. So what do we do now? Somebody else. Please, sir.
Well, it's asking for the rate of change of the surface area, so you need, I always just write down that part and then put a question mark for the equal, so ds over dt.
Yeah, you have to write down every rate that is mentioned. So it's mentioning the rate at which the surface area changes. So we make a note that that rate is important. It's perfect. 2 problems. Somebody else? Now what? Please. Yeah, again, we wrote down the rates to guide us as to what the equation should be. So we're supposed to be concerned about the quantity of the radius and the quantity of the surface area. In this case, it was easier than the last one, like I was saying to Keely, because they gave you the formula. Just write it down. So, Chanel. Any follow-up questions so far?
This is where I would do stop this right here.
No worries, so you're good to there. Sarah, please.
So whenever it gives you, when it has, because there's an equation in the question, is that usually the equation you use, or?
Usually is a good word. I can't guarantee there will always be, but it almost always has been. But you really should make sense of why that's the right equation.
Yeah.
Because I'm concerned with the radius and the surface area.
So we're just using that because it has the
S and R. Yeah, it's the whole idea. With related rate, you're writing down the rates so you can actually identify the quantities of interest. Because when you have a sphere, there's the whole sphere, right? There's the radius of the sphere, there's the surface area, there's also the volume. Well, this problem isn't concerned with the volume, so don't worry about it. But how did I know that? It's because in reading the problem, they only talked about the rate at which the radius changes and the rate at which the surface area changes. So we're only worried about S and R. Perfect. 2 more for Sarah. Anybody else? Question, or what do we do next? Either way. Please, Luke.
So in the other one, we had to relate the rates to each other. Like we had to draw the triangle and show how the different, I guess, how they reflect on each other.
Good call. Let me interject just one word different. You're on the right track. The difference was we weren't really relating the rates. It's what I said to, I think it was Hiram, I can't remember. In a related rate problem, you are relating quantities to start with. Oh, Karina, you start by relating quantities, you take a derivative, you discover how the rates relate.
Okay.
So you don't decide how the rates relate, that happens mathematically. So we wrote down the rates first. Somebody answer this, I'll give you 3. Pam, please. What is the purpose we were writing down the rates? I've said it like 12 times in the last 3 minutes. What's the reason we were writing? Oh no, okay, everybody. What's the reason we are writing down the rates? What's the only reason I write down the rates? So we got 2 people in, there's 3, there's 4, 5. I'll let you talk to each other and I'll still pay everybody 3 pebbles. Like, why are we writing down the rates? Don't say it yet, just want you to talk to them. Okay. Why do we write down the rates? Keyword is this. Okay, keyword is you got rates, you got quantities. Look at this down, get sharp. This column, this is not a rate, this is a quantity, it's an amount. This column is a rate at which that amount or quantity changes. So hands up, who knows? Why are we writing down the rates? Here we go. Allie, talk to me.
So we know which equation to use?
It's related to that, so we just add a little detail, So why are we writing down the rates? It is related to finding the right equation. Russell?
Show what we know and what we're trying to find.
True. Somebody else come on. Why, like this more specific, I've said it several times. Why are we writing down the rates? Healy? Pretty good. Somebody else. Why are we writing down the rates? Please, Lindsay.
Is it so we don't confuse the quantity and the rate?
That's really the key right there. Like, you got to keep separate. Listen, hey, I'll pay everybody else in a second, but 4 for Lindsay. You're trying to keep separate what's a rate and what's a quantity. And we wrote down the rates really to identify the quantities. So in this problem, the quantities were X and Y. We wrote down the rates to identify the quantities of interest. So in this one, what are the quantities of interest? Somebody, come on. What are the quantities we're interested in? Luke?
The radius and the surface.
The radius and the surface area. 2 for Luke. Okay, raise your hand if you were willing. Okay, a bunch of people had their hands up a minute ago. Raise your hand if your hand was up a minute ago. Keep your hands up. Write down 3 for that. Good. I'm kind of an extra credit fanatic. Give it away a lot. Just kind of in my blood. No one ever complains. I just sit back and just bring it on. Man. Ready? Catch that. Make it rain. All right. We good? Okay, so this problem, hey, key idea. We've got to come up with the equation. And Luke's answer to Luke's question is the similar triangles was all about coming up with the equation. They actually made it easier in this problem. They just gave you the equation. That's it. So now what? Somebody else hands. Come on. You learn way better if you're. The more I keep you engaged, the better you will learn. There we go. Keep your hands up. Everyone's hands up gets paid on this one.
That's what we're doing next.
Yeah, what comes next? Hands, please. Come on. Everyone whose hand is raised is going to get paid. Let's go, Abby. What? Of this equation. And when we do a derivative, it's got to be d over d something. So Abby, it's d over d what? Like, is it d over dx, dt, because it's related rate. So here we go. So how many would have honestly said what Abby just said? Show your hands. 2 pebbles, 3 for Abby. Oh, somebody else. Chanel, does this make sense? Let's go, Bailey.
Then you would solve it, so plug in the numbers that you know.
I'm going to keep going the derivative first. We want to use the derivative rules as much as possible.
Oh, sorry, I
No worries,
solved it.
no worries. No worries. Keely, you jump in 2 for Bailey.
You pull the constants out.
So what does this side become, Bailey? Keely, sorry.
Yeah, so we're dt.
Keep going, Keely.
And then it's going to be 4 pi d of r squared.
Good, 2 for Keely. Somebody else. Go, Ian.
Then ds under p equals 4 pi qr over dr.
Nicely done. Two for Ian. Does anyone have a follow-up question? Please, Lindsay.
So did you put up you left up the 4 pi and then put the r in the derivative because the radius is one of the quantities of interest?
Good answer. The key thing is that the r has to stay inside. I'll ask you the question and you'll know it.
Okay.
As you look at this sphere and it grows, is the value of r going to be the same or is the value of r going to be changing?
It's going to be changing.
Right. So because it's a changing value, it's a variable, so it has to stay inside the derivative.
Okay.
The only ones we're allowed to pull out are the things that aren't changing.
Okay.
So 4 is just 4, pi is just 3, so we're just pulling it out. Does that help?
Yes.
Two pebbles. Well done, Lindsay. Please, Hannah.
Are you asking like what goes next?
Yes, please.
Then don't you just plug in R and
Yeah.
R?
This one they made pretty easy. Just plug in the values.
What would be a harder one?
The only step at this point that is typically a little bit harder is you have to go over here on the side and do a little extra algebra to maybe discover the value of r. Like
what
instead of them telling you that r is 3, maybe they tell you the volume of the sphere is some number, and they give you the formula for the volume of the sphere, and you solve that formula to find r. No. It's not bad. It's not bad. You just have another equation, you do a little algebra, you find r. Like here's an example, I'll show you. Watch. 3 for Hannah for asking. It's a good question, Hannah, it really is. Hey, watch. They could have said this. The volume of a sphere is 4/3 pi r cubed. Okay? And they could have said, oh, okay, hold on a second. Nobody talking. I can't do it in my head. Come on. Somebody have a calculator. Ian's got one. Type this in your calculator, please. Go. Take 27, multiply by 4, divide by 3. Pretty good. That might work.
Oh, okay. That makes sense.
So take 36 times 3, please do it for quick.
36 times 3?
Yeah, what is it?
That is 9. Oh, sorry. Yeah, it's 1 way.
Divided by 4 is what? Good, it worked. Because I'm doing it in my head, so I make mistakes. Hey, Hannah, here's the difference. This would be a slightly harder problem. Instead of saying r equals 3, they would have said the volume is 36 pi. At the instant you're interested in, the volume is going to be 36 pi. Okay, listen to Lindsay's comment. Somebody answer this. I'll pay you on the first hand up. As this sphere grows, is the volume always, just say it out loud, is the volume always 36 pi?
No.
No, thank you. It's getting bigger and bigger. But at a given instant that we're interested in, the volume will be this. Okay? We want to know how fast is the surface area changing at that instant. Well, this formula for how fast the surface area changes, we have to know r at that instant. Well, here's an equation. All we have to do is solve this equation for r. We'll know what r is when the volume is 36 pi. That's not that bad.
I'm like, so I know to divide 4/3 pi.
So we're going to divide the pi first. Is that okay?
Yeah.
So I get 36 equals. Keep going, Hannah.
And then you divide the 4/3 over, and you'll have like 34 times that 36. Or.
So that inverts, right? Keep going.
And then I just am confused how you would do like the R.
So at this point, okay, again, I've got 4 numbers here. but they're all just being multiplying and they're just multiplying and dividing, so I can choose the order. So I'm going to do 36 divided by 4 first, which is 9. 9 times 3 is? So I end up with 27 equals r cubed. So something cubed is 27.
3.
So they could have given you a problem where instead of telling you the radius is 3, they told you at the moment of interest the volume is 36 pi. Now they would have given you the formula for volume. You don't have to have that memorized. But you would have to look at it and say, oh, I can use that to find the radius. Once I know the radius, I can plug it back in here. And does that answer your question? Anyone else have a follow-up? Please.
Is that kind of question common on the test, or is the one we're doing right now?
That's actually very common on the AP test.
It is very common on the
Sure.
The one in the purple or this one?
Both versions. They're really the same question. The only difference, Sarah, 2 for Sarah and also Luke, is that here they made it one step easier. You didn't have to find the radius, Sarah.
Yeah.
In this version, you would have just had to have found the radius. That's a common thing that happens in related rate. Chanel? What's bothering you?
Well, I remember taking the test last week and like I just did not understand it at all. But as we do it together, it makes sense. I can follow it and understand how to do it. So like I have no questions right now.
I get you. That's okay. Just what you want to keep doing is just related rate are a type of problem that really does sometimes just require some time. So don't get impatient with yourself. Just keep, every time it comes up that you make a mistake, you can just ask again. And every time we talk about it, you just keep searching for reasons why, try to search for reasons why you got stuck. Key thing is make sure, like if you made a mistake, that's easy to identify, you can fix those easily. If you're forgetting something, you can also fix that because you just get some flashcards. Just keep asking. 2 more for Chanel. Please, Harvey. So all that's left to do is they asked us to find the rate of change of the surface area. So they want to know the value of dSdt. Well, dSdt is this formula. So at the moment of interest, the radius is 3 and the RDT is -2. So that's 6 times, let's get here. 6 times 4 is, help me, 24. Times -2 is -48.
Pi.
Pi. Two for Hiram, 2 for Nick. Alex.
Just for the next question.
Please. 26, yep. Always nice when they ask the same one. Yeah. 'Job, Amanda. Hey, Lindsay made a comment a minute ago. It was really spot on. In the related rate problems, and in many problems, it's very important to keep track of the quantity versus the rate. The same thing is happening in this problem. A place where a lot of people have trouble is keeping track of the equation that is talking about the function itself, the curve, as we say, and then the derivative of that curve. So, question, pick up some pebbles. Here's an equation. Somebody, what's really one of the main reasons why this equation exists? Like, what's one of its main uses? Looking for hands. Please, Sam. It is, 2 pebbles for that. One reason is so we could find the derivative of this curve and see how fast, at what rate that curve is changing. Alec?
It's to find all the points on the curve.
Yeah, The first reason I believe is that we want to use this to find all the points on the curve itself. So this curve has some picture associated with it. We don't really know what that picture is, so we just draw whatever. Okay? But all of the points on that curve come from that equation. So are we interested in all the points on that curve? 1 point, 2 points, 3 points? Please keep it. Nice. So I just kind of guess and say maybe that's here. I don't really know. And what about that point are we interested in? Somebody. Like what information? Please. Nice. We want to know the tangent slope at that point. 2 pebbles for Karina and also Keely. So we're looking for the tangent slope right there. That is the question. It's exactly what we are supposed to find in this problem. Again, please don't hesitate to jump in with any question. I pay for any and all questions. Bailey.
So dy over dx is just like basically saying that when it's on the slope.
Yep. Think of it this way, Bailey. This is a graph, right? Slope means rise over run. How y changes with respect to x. That's why it's dy over dx. It's very good. Change in y divided by change in x. Perfect. 2 for Bailey, please.
So this y coordinates on F equal the tangent slopes on F side.
You got that backwards, so I'll say it back to you. The y coordinates of the f prime graph, every one of those y coordinates is a tangent slope on f. 2 for Juliana. Now what do we do? Please.
The derivative of y equals x y plus x squared plus
And differentiate this. So we come over here and start doing it. So we go y equals xy plus x squared plus 1. Take the derivative of both sides. Oh, we always have to know, is it going to be d over dt? Somebody else here, Brittany got the last two. D over dt, d over dy, d over dx.
dx.
Dx. Tell Alicia, because x is the input variable. Just take 2 points if I call on you, unless otherwise stated. That way I don't have to keep saying 2 pebbles over and over again. Kind of slows down the discussion. In class, you have to wait for me to bequeath the pebbles. We're in the official bequeathing period, so please, just every time you open your mouth and I call on you, mark down 2. Sure. The windows don't open. I wish they did.
Oh, goodness.
Design flaw. Well, there's that. I kind of like to keep my jobs. Please.
Is it too early to plug in?
Three pebbles for this one. Hey, 3 pebbles. Look. If you're trying to find the derivative and then plug something in, don't ever plug in until you've finished using all the rules. If you plug in too soon, you always get the wrong answer.
Why?
Because you haven't really finished processing the rules, you're really plugging it into the curve itself, which is going to find the y coordinate. Yeah, but then you're differentiating a constant, not something that really varies. The rules apply when it's a variable.
Oh.
The rules don't apply when it's a constant, different rules. Please.
How are you doing?
I'm great. 2 pebbles. Good work. All right. Next.
Oh, no.
2 for Abby. Bailey.
Split the terms up.
By addition. 3 terms, so we just do an addition. This is dy dx. Let's do it a little quicker, Bailey, for somebody else. Hey, so we're going to take the derivative of this, this, and this, because they're being added. So help me, Olivia.
You go, oh, 2x.
There you go. The derivative of this in terms of x will just be 2x. 2 for Olivia. Somebody else? Let's go here, Maddie. 0. Question? Questions? We have a question. Next step. Let's go. Let's try to look for somebody new. Back to Sarah.
So then it's x dy over dx plus y dx plus dx.
Gotta use the product rule. Well done, Sarah. So we have dy dx equals cy times dx over dx plus x times dy over dx plus 2x. One for Sarah. Please.
Does it matter the order between those two? Like if you put x dy over dx before y dx over dx, does that make a difference, or?
You know the answer, just tell me. Go ahead. Oh, the two things are being added. When you add things, does the order make a difference? No, so it doesn't matter.
Okay.
I always do it in this order, however, because it matches the quotient rule order, where things are being subtracted, and the order will make a difference. So I always do it this way to remind you of the quotient rule. No worries. So right here, we're finding the derivative of two things multiplied. So I have to use the product rule. So we take the second function y, multiply by the derivative of the first, swap. Does that make sense? Good work. Make sure you get a sheet protector. Well, you don't necessarily. Anybody else? Bailey? Now what? Come on, quick. Keely.
Now it's gonna be y plus x prime.
So,
So this is y prime.
yeah, so this is over there. So you put x there. So you got your x.
More for Keely.
Subtract 1, which is just 1, 2, and then 3x.
Yep. So Julia?
This is where I got.
Yeah, the same.
Got you said, I didn't know, were we trying to justify the increase for like divide? But if you divide, like, I thought, like, this is like y prime cancel out.
Can't do that. If you try to divide this side by y prime and this side by y prime, these divide to make 1, but these don't. Because these aren't factored. So that's not a good approach. What you want to do is get the y primes all together. 2 for Juliana. And then factor y prime. One second. Go ahead.
So how does that double function? You just change the divide of dx by prime. So there were
No, it doesn't. 2 for Abby. Anybody else? Alan?
What from step number, but where it says y 1 minus x, how did you get that?
From here to here?
The next one, from there
Here
to
to here.
there. Yeah.
I factor a y prime from both of these.
Oh,
So y prime divided by y prime is what?
1.
We have to close the door too early. Anybody else? 2 for Allie. So now what do we do? Luke. Dane. Nick.
Sure. Well, we can't solve because we have y and x. We need to go plug x into the equation to give us.
3 pebbles for that one. Without the we'll just pretend. Catch, ready? Can you catch?
Yeah.
Nice. Everybody look. I want the whole class getting this one. Whole class, look at me. Hold it, look up, hold it. You gotta close the door, I can't for myself. Good job. Hey, look. Come on, with me. Okay, everyone in the room. Okay, everyone who raises their hand who actually knows the answer. We started this problem by saying What's the purpose of this equation? Come on, hands up. Who knows? I'll pay everybody. What is the purpose of this equation? We stated it at the beginning of the problem. What is the main reason for that equation existing? What is the main reason, Ingrid?
Define some points
On the curve itself. Hard to know what to call that, but we're looking for the points on this curve. You use this equation to find those points. How many knew that before she said it? Come on. 2 pebbles, 3 for Ingrid. Okay, somebody else. I'll have the whole class again. Look. What was the goal of the problem? Whole class, come on. What was the goal of the problem? Hands, all who know, everybody. What's the goal of this problem? What's the objective? What were we seeking to figure out? Bailey? And this curve has one slope or lots of slopes?
Several, but we're just trying to find out that.
Very good. They want us to find the slope at just this one point. How many knew that before Bailey said it? 2, 3 for Bailey. What's the purpose of this equation? We went through a lot of work. Okay, the bulk of the work in the problem so far has been to find this equation. What is the purpose of this equation? Come on, hands. All who know. What's the purpose of this equation? What is the purpose of this equation? All who know. Okay, everybody. What's the purpose of this one? Olivia?
We can find all XY pairs on front of us.
Oh, excellent. You can find every XY pair on the graph of Y prime, for sure. How many knew that before she said it? 1, 2, 3 for Olivia. There's another reason for this, Olivia, everybody else. There's another reason for this formula that is typically more important for our class. What's the other purpose of this one, Effie?
Is it so you can plug in like the X and figure out the tangent slope?
Very good. This is how we find the tangent slope of this curve right here at any point. How many knew that? 2, 3 for Abby. Question, Sarah?
How would you get from, so if you go down.
There you go, hold on. Hold on. Go ahead.
So the 2 lines above the green box. So you go, so you go from there and you get the infinite to 1 minus x. Where did that?
So right here, we're factoring.
Oh.
Is that all you need? So like Sarah, this term has a y prime. It's really y prime times 1. This is x times y prime. So y prime is a common factor. So we factor it out, which means there's a 1 factor remaining and there's an x factor remaining. Everybody, paint everybody, so look, come on, focus, focus, focus. In this equation up here, which you all said the primary purpose of this equation is for finding all of these points. Okay, there's an x and a y in this equation. What does the x and y represent in this equation? And please, what is the x and y in that equation technically? A coordinate. It's really any point. The x and y represents 1 point, but it's x and y because there's lots of those points. So it's any point on that graph. When you get down to this equation, 2 for Nick, the x and y still represent any point on that original curve. We want the tangent slope at what point? Say it. X equal -1. What's holding us back from finding the tangent slope when x is equal to -1?
We have 2 variables.
There's 2 variables. There's the y, but they always go together, x and y. So we need to go find the y value that goes with the x. So how do we find the y that we need to plug into here?
We plug -1, the X, in the original equation.
Nicely done, Keely, because yeah, it's perfect. Because we know that at this point, the x coordinate's -1. And the whole purpose for this equation is to find points. So somewhere else on our work, and over here we'll do, we say we've got, help me Keely because it's in front of you, we've got y equals, what is it, xy? Plus x squared plus 1. And we plug in a x value of -1. So at x equal -1, we would have y equals -1 multiplied by y plus -1 squared. I always use parentheses when I plug things in, it saves mistakes. So that's y equals -y plus 1 plus 1. So move that over, that's 2y equals 2. Hey, y is equal to 1. So this point up here was actually -1, comma 1. Questions? Luke,
Can you scroll back down?
absolutely.
Wait, when you do the y. Oh.
So keep looking here, you're good.
Okay.
It all depends on the question. Like I can't say always that, I don't know. But in this problem, I'm trying to find the slope of that curve at x equals -1. And my formula for the derivative requires me to know the y coordinate that goes with the x equal -1. And those points always come from that equation. Does that make sense, Karina? Good. Welcome, Lane. Keely.
So now that you know the y, you can plug it into that equation and the negative x.
Perfect. So we can say at x equal -1 and y equal 1, y prime is going to equal 1 plus 2 times -1. Real game is over. Maybe not. No, we're at that bad time of the year when the weather outside gets warm. They have not turned on the air conditioning yet. That is the problem. So, like you can hear the fans, but all the fans can do is pull in outside air. So if the outside air isn't cool, it doesn't help.
So why do they not turn off the AC after school hours?
I can get them to leave it. There's no AC right now is the problem.
Yeah.
Yeah, I think they're very good about it. If I let them know that we have a big crowd, they'll keep the heating on, they'll keep it on. Then it wouldn't have helped anyway. Because it's on, you can hear it.
Yeah.
You're good. Yep. What's up, Bailey? Good work. Hey. Pebbles, man. Somebody talk. Hey. Go.
Okay, so I've never really known how to do it, but I think that you said both equations.
Two pebbles are a really good comment. Trying to remember. I don't know if there's 3 types, Keely, or just 2. But I know for sure there are 2 types of area problems. And one type is the kind you're thinking of, where they give you 2 equations of some sort, and they say these 2 equations form the boundary of an area. Find that area. That's one type. The other type I have seen, and there may be a third, is where they give you 4 boundaries. So instead of just 2, they give you actually 4 places. This one's giving you 4. With 4 boundaries, it's a lot quicker, actually.
So when there's 2, like, on this, one of the problems has y equals x as one of the boundaries. How in the world are you supposed to know?
Now stay with me. You guys are on the same kinds of questions. It's really good. 2 for Sarah. Look. So, hold on. 6. Yeah, look. There's 2 equations here. Now, one equation may feel uncomfortable. I'm going to get to your question second, Sarah. There's 2 equations here. One equation may feel a little uncomfortable because it's just y equals 4, but it's still an equation. And so when you have 2 equations, step number 1 is what Keely said. It is. But step number 1 is just set the equations equal and see where they intersect when there are 2 of them. Sarah, if one of the equations is y equal x, it's still an equation. You still just set one equation equal to the other.
But there isn't like,
Do you remember which one it is, Sarah?
yeah, it's like 28. Yeah, 28.
So we'll come back in a second, Keely. It really does fit with what you said, so. Yeah. Okay, so help me with the numbers here. There's 20, not 28. What was the other one? Quick.
15.
And what was the other one? 6? Okay, really? You solve 28 and 6 in exactly the same fashion. 28 and 6 are solved in exactly the same way. Because they both describe a region bounded by two functions. Even though, as Keely said, the one function is just a horizontal line, doesn't matter. We treat it the same way. So in both of those cases, you first set the equations equal. So I would have done this, Sarah. Okay, something big to memorize, everybody. Hey, when you see a quadratic, you don't try to isolate x. You get things all together on one side, so it all equals 0, and then you factor. This is a quadratic situation, so move the x over. Is everybody okay with that step? Or I can show as much detail as you need, just have to ask for it.
Why do you set them equal to each other?
We set them equal because if there are, you can answer this, children. You have two graphs, and somehow those graphs have to enclose some space. What must be true about how those graphs interact? They have to intersect. You set equations equal to each other to find out where they intersect. Yep. You're good. So first question, they're asking, so what's the goal of the problem? Between two things. Okay, Abby, the only way two functions can enclose an area is that those two at least intersect twice. So we set them equal to find out where they intersect. Then it's a quadratic situation, so I don't try to solve for x. I instead move this x over here. So I'm subtracting x, making that negative 4x, and I'm going to factor it. So that's how I find the intersections. Sarah, did that answer your question so far?
Yes. I just didn't, so I understood that I had to put them equal to each other, but I don't know, for some reason I just thought that y equals x was like weird.
No worries, I get that. No, that's why they give it to you, to make it feel uncomfortable.
Because I drew it and I just kind of did what you do with like whatever line. And then y equals x is that way, yeah. So that's, I don't know, I just didn't make sense.
It's no worries, no worries. You're doing just fine. Best thing to remember is that there are two equations that encircle an area. They're going to intersect somehow. It doesn't really matter what they are. So, anybody else? Keep going on this one. Oh, please.
So how does x minus 2 and x?
So look at this equation. This says that, so these two things added or two things multiplied? So two things multiply and the result is 0. What must be true about the two things? No. Two things multiply, you get 0. What must be true? Give me an example. There you go. So I don't look at them both simultaneously. I just say, well, if x is 3, will one of them become 0? What if x is 1? So there's two solutions. Please.
So is the 1 and 3 the two, so bounding it?
Those are the two x coordinates where the graphs intersect. So Sarah did remember correctly that this is this line. And I don't know whether this one's on the top or the bottom. It's actually going to turn out to be this. We have a follow-up question to there. We really need to make sure sure we know that this is top and this is bottom. How do we do that? Somebody else? Oh, Nick, please.
Plug in a number between 1 and 3.
So what number you want to plug in? 2. So one equation is y equals x. So add x equal 2, y is going to equal 2. So one of those equations has a point at 2, 2. The other equation, y equals x squared minus 3x plus 3. Add x equal 2. We get y equals 2 squared minus 3 times 2 plus 3 So one graph has a point at 2, 1, the other has a graph at 2, 2. Therefore, the line is above.
So you're looking at the y coordinates to
So I can tell that if I have an accurate picture. Because maybe the picture really looked like this.
And you need help in
When I set up the integral, I need to know which function is top and which is bottom.
you don't necessarily know.
Correct. That the picture is not the essential part. Please.
As I understand mathematically, like, why do you need a pickup point in between them that like logically like it's just not, I don't know, like why can't you just pick any point?
So do we care which function is higher, say over here where x is equal to 0? Do we care which function is higher, say over here where?
No, you're only looking at okay.
Does that make sense?
Yeah.
Oh, good question. Sorry, baby. Please,
Like, how do you know, like, to draw the graph like that? Like, you just draw a random.
just something random is just fine. Yeah, anything's fine. Just 2 things enclosed. Are you good to there? Follow-up question? What's that? What do we do now? Somebody finish. Nick?
We integrated it.
So set up the integral.
So, integrate from 1 to 3, y top minus y bottom, so x minus, x squared minus 3x plus 3 dx.
And 2 for Nick. The whole room has a possibility for some pebbles here. Raise your hand if you know the mistake I just made on purpose. Hands, please. Come on. I made a crucial mistake that will lead to the wrong answer. It will lead to a trap. You'll step right in it. You'll think you got the right answer. What's the mistake? Come on, hands. Now the cooling is turned off. It's much quieter, notice. Sorry about that. Lexi, please.
So I actually put parentheses in both of the.
Yeah, it's got to be x minus. I don't need parentheses around the x. That's the first thing. But I've got to have some here. How many knew that before she said it? 2, 3 for Lexi. So tell me what to do next. Come on, you guys talk. It works way better. Go, Sarah.
Well, since it's just subtracting, in this one you don't need the parentheses necessarily, so then it would just be x squared minus 4x plus 3.
Negative x squared.
Or, yeah.
Is that okay? That makes sense.
Uh-huh.
So Sarah just said, let's combine some similar terms here. Mistake though. Oh wait, so it's x squared. What does it say again?
So negative x squared, and then it would be plus 4x minus 3x.
There you go. Question?
Is that just from distributing? the
Yes. Distributing the negative
And then adding.
and then adding the x with the positive 3x. Good job, Keely. Anyone else?
No, wait.
Weighting is fine. Chad, please.
Wouldn't, if you distribute them negative, wouldn't the x still be outside of the parentheses, so you have to distribute the x too, or no? Why would?
The x that's over here, Chad.
Yeah, why do you just add it into the full?
Good question, good question. It's really x minus all of that. So the x isn't distributing, it's not multiplying at all. It's just there, and this is like -1 times all that. So you do the distribution first. What you get is this. So now what I have is nothing is being multiplied really. I just have 1, 2, 3, 4 terms that add, and I just combine those. Sorry about the spring warmth in the room.
So it says that it's, so once you factored in the negative, it looks like it's x minus x squared plus 3x minus 3, but then you go, and then the next step down becomes 4x. Is that? Oh, I guess, oh, the x has a, okay, never mind, I forget, we're good.
Two pebbles? Please, Stevie.
Can you take the and the derivative of that? And you would use the two different ways, right? So it's up.
Add, subtract for sure. Just break them up.
And then one of them would be negative x cubed over 3. And then the other would be 1 over 4.
No, stop right there for a second. The 4 is just a multiplying constant, so you just write it down.
But
The next
isn't
one's
it
x.
like that
What's that?
ax plus b?
You could use that, but you never want to, because what you have, you're doing just fine. This is like ax plus b to the first.
Oh, yeah.
Whenever you have ax, you just don't use it. Now your thinking was very good, just we just don't use it. So instead we say this is a 4, it's just x to the first. So what is it cubed?
So it's x squared over 2.
9. And then what's the antiderivative of 3x? Does that make sense to you? That's good. Calculus is over, arithmetic begins. This is where 6th grade pays off. I don't know, what grade do you learn all this in nowadays? Fractional addition, what grade? 5th grade, 5th grade pays off.
I know. Okay, so I got the right answer, just not the right sign. I put it when I did it out.
Just one quick question. Did you start with x minus the other function, or did you start with the other function minus x? So right here, when we set up the integral, the very first step, did you take x minus the other function, or did you take this function minus x?
I did x minus
That function. When you plugged in, did you plug in the 3 first minus plug in the 1, or did you plug in the 1 first minus the 3? So you just lost a sign somewhere. So we'll step through it quick.
Oh, I know what I did.
Okay, actually go ahead.
Sarah, what's she thinking?
Actually, Sue's that I know where.
So for, I messed up so I can't find it.
You're fine. Hey, look. Is everybody good to hear? Anyone else? Abby, please, sir. You sure? Okay. I'm just going to switch to the solution I had done earlier. And it just makes it a little faster for all of you. It doesn't matter to me. So, Karina,
I know what I did.
you find it?
Yeah, I just.
Which number is it, Sarah? Help me.
28.
What'd you do, Karina?
I, subtracting the 3 and 1, I added them.
You put a plus right here. So here's our antiderivative, Sarah. And then I'll just let you stare at it so you can find your mistake. It's probably easier. It's only 40 minutes until the completion time. I will tell you that when there's a good crowd, sometimes we like to do a music quiz at the completion of the evening. So if you were willing to stay till 6, you can pick up on a very large pebble bonus by just being part. Well, so assuming you're good at guessing songs. Some people just decide if they're going to take the song.
I think the higher the
Good job, Albert. Lydia as well. Well done.
All I know is Taylor.
You're amazing that we can't see her.
Guess any karaoke song. Because I know what it sounds like.
You're being a question.
This is literally the only two. Carrie Underwood, early 2000s. Rascal Flatts, I think it's some Rascal Flatts songs. I just know old, like 2000s country. I don't know any of them because I listened to like country as a younger. But no, not a lot.
I promise Keely 15, so we have to go back to her.
Musicals, I can do right musicals. They sound good. And any like pop song of the 2000s.
Sarah?
I can get those.
Who else on this one? Last chance. Hard. I'm doing great.
I feel like I just keep
Oh, great. I understand this conversation question. Why did you, okay, does it matter what John played first?
Oh, yeah.
Now I need to spending the money I'm making tonight. Oh, I just did 2 years.
Pretty good? 15, Keely, right?
No, I tutored for this other kid at 7 years. So it's not even doing my second.
Is there ever going to be a homework number?
I don't recall any like that.
I do math.
I always say that because I don't know, they get their own questions, I don't. You know what I mean?
I, for math, I'm always just like, all right, focus, and physics,
Other than, there are problems where they give you a picture of the one, which is a lot easier, because they just show you the boundaries. There you can have 3 boundaries. That makes sense.
Yeah, I think she mostly wanted me to
Without a picture of only seeing
like set aside a time to get his
I always say, because maybe
but if someone would like watch over it, and like
I have a pretty good memory for this stuff, but I think those things are It's always nice you guys do that.
yes, it is. So I'm not gonna complain. Like I sit in their nice house.
Hey, time for silence.
Like no one does.
Block Rolly over there, so.
And I only work 4 hours a week.
Alicia. Don't worry. It's all good. Okay, the difference between this problem and the previous one is they didn't give 2 boundaries for the area, they gave 4. No. No sighing. Hannah's, no sighing. Hannah always sighs. Like, it doesn't matter. I swear to God. As soon as you had one, never mind. Okay. She does every time. It's true. Just because you add one thing doesn't mean it makes it harder. Sometimes it means it makes it easier. So.
Well, with the X and the Y axis, does that just tell me that it's going to be like positive the whole time?
It's telling you that area of the region is bounded by, so you just start drawing it. Y-axis. X-axis. What I said to Keely, there are 4 boundaries. Now I know 2 of them. 2 for Juliana. What's the other boundary? Either 2 axes. Do the easy boundaries first. It makes the problem easier. 2. Where's that, Russell?
X equals 2.
Where's that?
It's above.
Up here?
Yeah.
I'm going to ask you a follow-up question. If I drew a line here, would this x-coordinate be 2?
No.
Would this x-coordinate be 2? Not necessarily. That's not the line x equal 2. The line x equal 2, Ryan, is where every x-coordinate is 2. So Ryan says this one. So Russell, is this x-coordinate, so this is x equal 2. Is this x-coordinate 2?
Yes.
How about this one?
Yes.
How about that? Does that make sense?
Yeah.
2 for Ryan and 2 for Russell. Alyssa, you good?
Yeah, it was just bad. I didn't raise my hand.
No worries. 2 for Alyssa. Okay. Sarah.
You can, well, it's just, so whenever it's asking for a tangent, then I take the derivative of the equation equating.
I can't say always, but that's common, yes. Okay. Look, The last boundary is e to the 2x. Okay, everyone in the room is going to get a pebble for this if you know the answer. I've said many, many times in class that when you have e to the something, you must memorize what the result is always. Oh, no, come on. Who knows what I'm thinking? This is e to the something. It's e to the 2x. X could be anything. E to the something is always blank. Gotta have this memorized. E to the something is always blank. Randy? Positive. How many knew that? 2 points, 3 for Randy. So when I graph this function, even if I can't remember what it looks like, I know it's always positive. It's not down here at 0, it's up here somewhere. It actually looks like this. Watch me, hey. It looks like this, but if you drew it like this, would it change how you set up the problem? So who cares? So how do I set it up? Somebody. Like really, 4 boundaries, which is easier, 4 boundaries or 2? 4. 4! So I don't know why we're sighing about 2. So sorry to get back to you. What's that? Because we know the boundaries completely now. So what's the integral that I set up to do the integral? 0 to 2.
Yeah, 0 to 2.
0 to 2. The other one we had to find the intersection.
Okay.
Make sense? Yeah. That's what I say. Don't just sigh because there's more information. Maybe it's easier. So it really is a good. I know people always say they want life lessons. That's a good life lesson. Like analyze the situation before you panic. Right here?
Where the other places meet.
Like here?
Like
Up here.
Are there any other ones?
Only the x coordinate. That's all we worried about on the other one, remember? So just the x. Do we know this x coordinate?
No. Oh, yeah.
Yeah, there we go. We know this x coordinate.
Yeah.
So now what you do is how much is bottom?
Huh?
So either 2x minus 2.
What's this?
0.
Ah, shoot. E to the ax plus b rho. When I state a rule rapidly, I'm kind of hinting that you need to have it memorized. When I state a rule rapidly, it's my hint that I probably need to have that memorized. That's why I'm telling you. E to the ax plus b rho. Yeah, the memorization part, that's, you guys have to do that. I can't memorize things for you. Wish I could, I just can't. It'd be awesome, you just sit in the room and just go, Mr. Smith, what's this? And just telepathically tell it to you all set.
That's true. That's if you don't
That's
have
part of the rest of my life.
What if you're doing
Like every 2 minutes, you're
training?
telepathically paging me, you know. Oh, well, you're in the Civil War begins. 1861.
Please.
I'm just stuck at the bottom.
3 2 then 3, because they asked for 2.
Wait.
Oh, 3 as well, we'll do 3 then 2.
Let's not go yet.
3 1, sorry.
What?
3?
Yeah.
Okay.
Wait. No,
Oh, wait. Ah. Right, so right here. So I need the anti-driven. So I use this one.
Yeah, he just like showed up. It's weird. I feel like he was waiting. Just like around the corner, just waiting for kids to come ask.
Keely.
He showed up real fast.
So one graph made us work with one, but it says
Also, I was so worried that when he went on like the dirt thing, that he would just fall off and die.
They just distributed it.
No, but I was thinking about it. I was like, what if he just like disappeared? Like, what would we even do?
When you multiply a fraction, Keely,
Would you?
it's got to be top times top, bottom times bottom. This becomes this. What's 1/2 times 1?
Oh,
I wasn't gonna follow them.
Good. Everybody else good? Complaining?
Yeah.
Which one? 3. Never done one. I'm going to show you this one because there's a lot of steps. And I want you to just tell me where you got stuck. Is that okay? Okay, no, look. Look at 3. One of the best ways to learn is to ask questions. One thing you're going to have to do in college is learn to ask questions effectively. So this is a good practice for that. I'll answer anything.
So like when you like read this whole thing that like you got.
Outstanding question. Outstanding. It said the words equation of the line tangent. Okay, a few years ago, I really made a big deal about the fact that every time I read the words equation of the line tangent, I draw my favorite picture. That's why it's immortalized on the wall. Okay? So I draw that. And I label it. And Abby, I'm serious. Like every time I read the words equation of the line tangent, or even if I read the words line tangent, I'm drawing this freaking picture. Okay? I was struggling to use that word effectively. I feel like I'm swearing terribly. Brittany says I am.
No.
Oh, sorry. What can I say? Draw this freaking picture. I feel like I'm being very vulgar.
No.
Just tell us you're being vulgar, don't worry. We'll just say you're being vulgar and you do it.
No! Hey, we good here? Abby? So draw the picture and label everything. The curve has an equation. Somebody, hand, come on. What's the purpose of the curve's equation? Come on, somebody. Go. Find the x and y pairs of the curve, right? 2 for Karina. I label the point. They found one of them for me. I label this line. I'm going to give everyone in the room pebbles for this. Everybody. Karina just said that the purpose of f of x, this equation, is to find every xy pair on this curve. Okay? This line has an equation too. It's right here. And if you kind of fast forward to the end of the problem, it turns out to be this one. So, what's the purpose of that equation? Oh, no. Hands, please. Come on. There's a big connection here that you're not quite seeing, but I need you to see. So the question is, Karina correctly answered. Again, math, life, learning, it's all about connections. You've got to connect things. This curve has an equation. The purpose of the equation is to find every point on the curve. This line has an equation. It turns out to be this one. What's the purpose of this equation? Oh, no. It's not a trick question. If it feels like a trick, then you know the answer. If it doesn't feel like a trick, then you probably don't know the answer. What's the purpose of this equation? Sophie?
Equation of the line tangent to the curve.
It is perfect. No, 2 pebbles for that. It's perfect. What's its reason for existing? What do we use it? You're fine. What are we using it for? Alicia?
To find every point on that line.
Perfect. This curve has its equation. It's right here. This curve has its equations to find every point on that line. So how many knew that before she said it? 2, 3 for Alicia. So that's what I start with. Please.
Would you use that equation to find tangent slopes on the curve though too, or no?
No. Good question. This equation right here is not for finding tangent slopes. It's for finding points on that line. That's really good. Does that make sense?
Then what's the one that we always use?
You're doing great. You just got to keep connecting a little bit. So, Keely, F is the equation for finding the points on the curve. This is the equation for finding the points on the line. F prime is how we find the slope anywhere on the curve.
So if we get the derivative of f,
Then we get an equation,
then that's the equation two.
the slope anywhere on the curve.
The tangent.
The tangent, yeah. When I say slope on the curve or tangent slope means the same thing. You okay with that? Okay. Good.
So
the answer, that's not like, if you find the derivative of that, that's not holding out.
Nope, different purpose. That's really good. This is for finding every point on that line. This is for finding every point on the curve. We want to find that, we know that this line goes through this point, so it helps us find this equation. We've got to find the slope of that line. That's what we use F prime for. Follow-up question?
If you were to plug in an x value for the A equation, what y value would that be?
Watch me. So let's plug in x equal 1. You help me. What's negative 7 times 1? Plus 6 is? See, this is an equation. Stay with me, Ingrid. This is an equation for finding any point on that line. So by plugging 1, I've got to find negative 1, because that's a point on the line. You plug in, say, I don't know what a 2 is in this picture. You plug in 2, what's negative 7 times 2? Plus 6?
8.
Negative 8. Okay, I draw the picture quickly because I don't really know what everything looks like. The real situation is a little bit different. The real situation is we have a curve that there's a point at pacing. Whenever I go to the zoo and I watch the tiger go like this, like I feel for you, buddy. I live your life. Just kidding. Terrible joke. Okay. It's not like a tiger in a cage. You guys are just watching the tiger all day long. Just like this. That's all I do all day long, back and forth, back and forth. And I sit over here for a second and say hi to Adam. Back to pacing. Okay. Talk and move. So one point is at 1, negative 1. Look. 1, negative 1. Another point was where? 2, negative 8. The line really looks like this. We don't care. But I'm just emphasizing to Ingrid that the point of this equation is to find points on the line. The line. The tangent line on the line, not the curve. This is how you find points on the curve.
Right, okay.
Hey, are we good? Stop talking. Follow-up questions? So we're trying to find the equation of the line tangent. I know most of the equation because I know a point that is on the line. It's x equal 1. I know the corresponding y coordinate on the line. That's y equal negative 1. I just need the slope of that line, which means I need the slope of the curve at 1. Take the derivative, plug in 1.
That doesn't work.
Product.
Wait. What did you just say? Go back.
Try to find this equation.
You have the x first.
The x value is
And you have
1.
y.
Y value is negative 1. Got to find out.
Okay.
M is the slope of this line, right?
Yeah.
Which is also the slope of this curve at that point. The curve has many slopes, but where the line is tangent, the curve and the line have the same slope.
Wait, but isn't the slope on the curve the y of that tangent?
No.
Okay.
Y on that prime.
Right, okay. Okay, yeah.
There?
Yeah.
So I find up prime. Here's the word.
That is way too much.
This is on the internet, by the way. You can take a picture if you like, smile. Sophie takes way too many pictures of me all day. Like I live in morbid fear of what I am on the internet. It's like I fear that this is just, Abby's laughing because she knows it's true. So she's like, it was just a failing opinion of pictures. Abby's laughing because she knows the truth. Dude. But you know, freedom of the press and everything.
Oh.
What can you do? I just trust that Sophie has a good heart and she would not treat me as huge programs. Please. Okay, it goes back to again. So ignore all the detail for a minute. Got to sort out again the meaning of the equation. So you tell me, Keely, what's the purpose of this equation? Good. What's the purpose of this equation? Nicely done. We went to a lot of work to find an equation for f prime. It's right down, this is the one I should have boxed it. So here's my equation for f prime. What's the purpose of this? Good. How many different tangent slopes does the curve line have? Infinite. Which tangent slope do we want? That's why you plugged in x equal 1.
So I got checked between 6 and 7.
Okay, between 6 and 7 I factored. Losing my voice, sorry. Between 6 and 7 I factored because I have two terms, Sarah, here and here. This is 3 factors. What are the 3 factors?
1 minus 2x.
3 times. What are the factors here?
Well, it's 6x, 1 minus 2x, 1 minus 2x.
So what's common?
1 minus 2x.
2 of them.
Oh.
You see it now, Abby, please?
I'm sorry, why is that? Okay, I think it's just a question.
You're okay.
So we would like
No, it's cubed and squared, not root.
oh wait, yeah. Okay.
You're fine. So look here, you're good. So you came in the class halfway through, so you haven't heard the way I explained this, no worries. So what you see here are 3 factors, 3 things being multiplied. You tell me what are the 3 things being multiplied. Perfect, see that? Okay. I see 4 things multiplied here, what are they? Yeah, the negative don't worry about it. 6 and x and twice, right? So in this term, there are some factors that are also in this term. What are those factors that are common or shared? Good. So I took out 2 of them. So you got 2 of those factors, you're left with 1. Take these 2 out, you're left with just 6x. You see that? Ingrid, talk to me. Talk to me. So Ingrid, for factoring, you see that? Keep talking to her, Chanel. Please.
So when you plug in f prime of 1, you were looking for the slope,
The
right?
slope of the curve at x equal 1. That's why it's called f prime. Slope of f at x equal 1.
Because I get plugged in and
Plug it into f. Oh, m. I couldn't hear you. I was too far. Sorry, M. I thought you said f. Sorry. I'm like, what? You just have to get on the web. The u should be x squared plus 2x. Yeah, the u, you choose u first, then you take the u. You don't have to. You don't have to. You don't have to factor. I factored on purpose because some problems you do have to factor. And I thought, oh, there's a good chance to kind of show you some factoring. Please.
the difference between
He doesn't follow it.
That's the next one we're gonna do. Number 2. Right? You good? Thank you.
Okay, like I understand why, but I don't understand why.
fine.
Like why finding the y gives you the tangent? Like,
It's because of the definition of f prime. The symbol f prime literally means, like there's an f graph and there's an f prime graph. And you memorized long ago, you just forgot. But the y coordinates on f prime, every one of those y coordinates is a tangent slope of f. Every y coordinate on f prime represents a tangent slope on f. So you have an equation for f prime right there. I boxed it in purple, right? That equation, plug in an x, you get a y. Well, the y is a value on f prime. It's not a y on the original curve. I think what you're mixing up is there's 3 things going on here. There's the equation for the curve. Okay, that's right here. Okay, that's how you find all of these points. There's an equation for this line. That's this one. That's how you find all of these points. And there's another equation, f prime. F prime is not displayed here at all. F prime is some other graph.
so f prime and then that y equation, the y equals m times the x.
Yeah, those aren't really very related at all.
They're not the same thing.
Oh, not even close. They're not, listen, they're not even related at all, hardly at all. Like, everyone hear that? Hey, listen close. It's really common to mix this up. This equation is not, it has hardly any relationship to f prime at all. Like, almost zero. It's just another line. Okay, the only thing it has in common with f prime is that right there it has the slope you get from f prime. And that has nothing to do with f prime. F prime is a completely separate equation. It's its own graph. It looks completely different than all this. We don't even know what it looks like. F prime is some other function over here doing whatever the heck it does. I don't know. But what's the purpose of f prime? Like, what's one of the main reasons we keep finding f prime?
So we found f prime to find the slope to put back into the equation that y
Yeah, because this f prime, hey, f prime is how you find the slope of f at any point. The tangent line has the same slope as f at 1, so that's what we need it. Let that settle for as soon as it works right for that settle. You ready to go to 2? Ingrid? Sure.
Yeah.
Ready? 2. Okay. Ready, break. But that idea, hey, it's hard to make a prioritized list and say this is the most important, then the next one, and the next one. But there are groups of ideas that are like extremely high in importance. One of the ones that's extremely high in importance is you have a curve. You have an equation for finding the points on that curve. Done. You have a derivative of that curve. That's how you find the slopes along the curve. That's not the tangent line. Like, how many tangent lines does this curve have?
Infinite.
Infinite number of them. They're all different equations. They're not f prime. F prime is something completely different. Okay, here, look. Question says, here's a function. Which of these are true? So AP Test always does this. They're very clever. They never give a straight up true false statement. They always give you some true false. It's like, answer the following 6 things are true or false. Yeah, AP Test. That's why the AP Test has value. If it didn't have value, no one would accept it. Like the universities would say, oh, we're not giving you credit for that test. Has this happened with other AP tests? Yes. It hasn't happened with the calculus test. Because it has value. So, does that make sense? Limit. To find limit, first thing I think of is I need to find the limit of f. So I would first factor and divide if I can, but there's no dividing there, so I'm done with that. So I just plug in numbers close to 3. So I say, okay, let's see what happens here. So f of a little less than 3 is going to be pretty much the same as a little less than 3 plus 2 is pretty much the same as 5. Plug a little more than 3. Let's see, that's going to be 4 times a little more than 3 minus 7. And that's pretty darn close to 5 as well. Therefore, the limit as x approaches 3 is 5. Okay, warning. The way I just did that is perfectly suitable for multiple choice. If it's an FRQ, I've got to write out my notation a little more formally.
So a limit is only talking about the 2 points, not the one in the middle.
Perfect. The next question is talking about all 3.
Yeah.
To be continuous, all 3 values, f of 3 minus, f of 3 plus, and f of 3 must all be the same. So f of 3 is this. So now I know it is also continuous.
Yeah.
So true, true, and true.
Then differentiate.
Yeah, sorry about that. You're okay. Are we good to there? Oh, wait a minute. Please. Go ahead. Yeah.
How do you know that f of 3 is
So I read the function. It says to find any value of f.
Oh, is that what that equation is? If x is
Equal to 3.
Oh.
So right here, if the x value is equal to 3, use this equation.
Is it say that? Will it?
Then it would be f of 3 is undefined. Because the definition of the function here would have no instructions on how to find f of 3.
Okay, so number 2, like, maybe possible, but
Yeah, because this is which defined have to be true. Well, actually, if this says x, if this does not say equal, this is for sure false. Because there is no definition for what's happening at 3. And if the function, everybody memorize this, please. 1 second, Randy, sorry. Please memorize. If the function is not continuous, it's not differentiable. Has to be continuous first. Randy, then Abby.
sorry, can you explain why you
For the function to be continuous, the limit from the left must be exactly the same as the limit from the right. Okay, but that just means the limit exists. So first of all, we find the limit was 5. That does not guarantee continuity. To be continuous, not only must the limit equal 5, the value of the function at 3 must also be 5 as well.
Okay.
Does that answer it?
Yeah.
Good.
Like, you were saying if it was like FRQ, you want to like.
I'll be more formal. What I mean by that is this notation is not accepted on an FRQ, these two here. It's what we think about when we're solving the problem. But mathematically, what you have to write, if it's an FRQ, is what I wrote here.
Yeah.
The limit as x approaches 3 from the left is really the limit as x approaches 3 from the left of this formula. Okay? You don't have to write this since stuff if you don't want to. I did that so you could follow my solution. On the AP test, you could say, which is equal to 5. They'd be happy with that. Then you say, then you jump to here, and you say, right, where is it? You just write this again, basically. You say the limit as x approaches 3 from the positive of f is the limit as x approaches 3 of the other equation, which is the 4x minus 7. You say that equals 5. Then you just say, therefore, the limit's equal to 5. That's all. Back here. Is everybody good to hear?
Yes.
Question is differentiable, right?
Yes.
Good. Gotta have something memorized. I mean, your job is to get it memorized. Okay? First thing you should have had memorized is a function to be differential must be continuous first. Got that? Second, even if the function is continuous, it still cannot have a corner or a vertical tangent. I'll be Perfect, perfect. We don't know yet. We don't know yet. We can do something to find out, Bailey, but like right now we don't know. So we don't know if it's differentiable or not because we don't know if there's a corner or a vertical tangent. Other way around. So first must be continuous, and then Abby, it cannot have a corner, and it cannot have a vertical tangent if it will be differentiable as well. The reason being, if the function has a corner, you don't know the slope at that corner, because the slope changes too quickly. Like, look at this. Okay, that's an example of a corner, where prior to this point the slope is one value, right after it's something drastically different.
So it's like the definition of differentiable, the ability to find
Uh-huh. So if you have a corner, you can't find the slope, not differentiable. It's a vertical tangent, Ingrid. The curve has a place where the tangent is vertical, slope of a vertical line is undefined. Think.
Going back a little, so for the limit exists, like a little bit more, a little bit less, the same exists, and it's all the same.
Okay, so the limit was just a little bit more, a little bit less. Continuous was the limit first, then plug in exactly 3. And they gotta all be the same. And it's continuous. Now we're checking different.
Sorry, does number one work because when you plug in 3, like a number from now?
No. Number 1 is only true because you plugged in a little less than 3 and a little more than 3 and got the same value.
Okay, I thought that was the same for 2.
No. 2 is, first of all, it's hierarchical. Meaning if 1 is false, the rest of them are false.
And that's always.
If the limit doesn't exist, it won't be continuous. It's not continuous, it's not, so it's hierarchical. Make sense? So I first check this, number 1, a little more, a little less, I get 5. All I know is the limit exists. To see whether it's continuous, well, the limit had to exist first. If the limit on one side was 5, the limit on the other side is 6. So now I check continuity. Well, to be continuous, first the limit must exist. Second, the value of the function at 3 must also be 5. So I plugged in exactly 3 and got exactly 5. Because these 3 things are the same, the limit exists.
So on one,
That's right, the correction is continuous.
so on 1, 3 minus, like a little less, or 1, 3, the same, and then on 2.
All 3 have to be the same. Yes. You good? Okay. We got to make sure there are no vertical tangents or corners. A vertical tangent is easy. The only way to get a slope that is straight up and down, okay, is if the derivative has some sort of expression where you end up dividing by 0. So first thing is take the derivative. It's a piecewise function. Taking the derivative of a piecewise function is extremely easy. All a piecewise function means is that instead of having one formula to find all the points on the function, there are 2 or 3. So here they are. So picture the graph. We're over here where x is less than 3. There's one formula for finding all these points. Here we are where x is greater than 3. There's one formula for finding all these points. They're just different formulas. So how do I find the slope of all these points? I take the derivative of this formula. How do I find the slope of all these points? Take the derivative of the other formula. So that probably looks like this. What's the derivative of x plus 2?
0.
Ouch. What's the derivative of x plus 2?
1.
1. That's valid for whenever x is less than 3. What's the derivative of x? What is it? 4x minus 7? 4. That's when x is greater than 3. Okay, the reason I did not put an equal sign is because if this graph has a corner, you cannot find the slope at the corner. This graph has a vertical tangent, you can't find the slope at the vertical tangent. So pay attention here. My slope doesn't have a denominator, so the slope can't ever be undefined. So I don't worry about vertical tangent. Before I get to 3, the slope of, remember, f prime means the slope of f. So before I get to 3, the slope of f is 1. Right after 3, the slope of f is 4. Is that a corner or not a corner? Corner. Slope changed abruptly. An abrupt change in slope is a corner. So I can't put an equal sign here because I can't find the slope at a corner.
What if it's like 1 over apart?
Doesn't matter. For our class, they won't make anything too complex as long as they're different in any way. Then it's a quarter. Like Keely, for our class, it really could be 1 and 1.01, that would still be a quarter. The only way they're going to be the same is that this is like 0.999999999 forever. And this is like 1.01 forever, and then you say they're basically the same. Quarter. To be the same, they got to be the same. Or like I said, that kind of limiting sameness. I've never seen it. For instance, tangents. To get a slope that goes straight up and down, the slope has to be some number over 0. But these slopes are never going to be something over 0. Sarah.
That's why I'm kind of like, introduce me to people doesn't mean create the drama. Like, you tried to stop it, like, it's like your fault.
More than 3, why did you got
Please don't blame yourself.
This number right here is
Don't worry.
you can't plug in exactly what it's recording. Well, I know what you're doing. No, stop. I know what you're doing. If you plug in a 3 here, yes, you still make it. But you should mentally be thinking of one so that you know you're supposed to do this. Burrito. Not this one. That's why I always teach you a little more. Stay away from the crazy tricks or oh, because it's 1 divided by 1 is 4 divided by 1. Like there's no value of x which will make that something divided by 2.
I don't know.
Only you gotta driven a little different.
Oh,
So if you found the derivative, it looks like this.
Hands down. Like he's mean.
Now there's a value of x which will cause the derivative to become undefined. 1. So when x equals 1, this the function f, not f prime. Function f would have upward potential. The rule only works for 1 over x. Just 1 over x. If you look at the yellow part, the rules are extremely specific. Look at the derivative rules I use my little trick where I say 1 over something. Notice that they didn't do it, don't say that 1 over x.
There's going to be times when I take it out, I have to call me out. I'm going to fix it.
This is the quarter, that doesn't mean you're going to jump or okay, so here's the deal. Everyone look up, no one talk. Look at me. So here's the deal. It's up to you. I need to go. If you would like to stay for a few minutes and earn extra pebbles via the music quiz, you may stay. If you're going to stay, you got to abide by the music quiz rules. So the rules are you can't talk when we're playing the selection. So if you aren't going to stay, we'll let everybody pack up and leave. Who's leaving? Don't worry. Your part.
He's so cute. Wait, what's his name? Oh, and
Also like,
how far were you going?
I want to say